In this video, I'm going to introduce you to the concept of uncertainty, as well as some basic calculations you can do with uncertainty. In physics, we make a lot of measurements, and since no measurement can be to infinite precision, there's always going to be some uncertainty involved in it. To help you to understand this, we're just going to do a simple measurement. Let's draw some dots on this page. I actually don't want them quite that in line, so I'm just going to erase that one and put a new dot on here. Okay. Let's figure out what the distance is from dots 1 to dot 3. Well, first of all, let's measure the distance from dot 1 to dot 2. So we can get out a millimeter ruler and make a measurement. I feel I've aligned that as well as I can. And we find out that the distance from dot 1 to dot 2, well, that looks like it's in between 5.5 and 5.6 centimeters. So how I'm going to state this value is I'm going to say the distance from 1 to 2 is 5.55 centimeters. Now there's some uncertainty on this. I know that this dot is somewhere in between a line or it's on a line. This measurement right here, it looks like it's on the line. This measurement right here, it looks like it's in between lines. And that's the resolution of a millimeter ruler. You can identify whether something is on a line or in between a line. So for every single measurement, there is an uncertainty of 0.05 centimeters or half of a millimeter. So I could also state this as plus or minus 0.5 millimeters. Okay, so since I had to align the ruler in this leftmost position and in this rightmost position, my total uncertainty of this calculation would be 5.55 plus or minus 0.10 centimeters. Now where does this 0.10 come from? Well, all I did was I said 0.505 centimeters plus 0.05 centimeters, the uncertainty on both my measurements, is equal to 0.10 centimeters. And that's why that's my total uncertainty. Let's now make a measurement from point 2 to point 3. I've aligned that to the best of my ability, and I find out that the distance from 2 to 3 looks like it is 5 point. This one's kind of tricky. I don't know if it's on the line or if it's in between the lines. I'm going to say that it's on that line. You may disagree with me, but that's why we have uncertainty. So I'm going to say that that is 5.70 plus or minus 0.10 centimeters. Once again, I have uncertainty on this measurement right here, so I have to add together the uncertainty on both the leftmost point and the rightmost point. Now you may ask the question, well, if I can't tell if it's 5.70 or 5.75, can I put in 5.73? That is perfectly acceptable. You could put in 5.73. However, it does not change the magnitude of your uncertainty. You would still say the magnitude of your uncertainty is plus or minus 0.10 centimeters. Now, We want to know what the distance from 1 to 3 is. Well, we simply add the magnitude of 5.55 plus 5.70 to figure out that my total distance is 11.25 centimeters. And then I have to add together the two uncertainties from my two measurements. So that'd be 0.1 plus 0.1, giving me an uncertainty of 0.20 centimeters. Now I technically haven't stated this correctly. You'll notice that these uncertainties right here are both stated to two significant digits. That is perfectly acceptable because the leading significant digit is a 1. And when you have leading significant digits starting with 1, you state them to two significant digits. You'll notice that the leading significant digit here is a 2. Zeros before the decimal, this guy right here, is insignificant. Because this starts with a 2, we must state our uncertainty to 1 sig dig, and this comes out to 11.3 plus or minus 0.2 centimeters. You'll notice that the precision of my uncertainty is to the tenths place. Therefore, the uncertainty of my measurement must also be to the tenths place. So you match precision. When I use this word precision, I'm talking about the place value, the whole, the tens, the tenths, the hundredths, and so forth. Okay, so to recap that little detail I gave you, uncertainties, which I'm going to call UC, have 1 sig dig if the leading value is not equal to 1, and 2 sig digs if the leading number, or the leading significant digit, is equal to 1. Okay, so we have our value, we have our distance from 1 to 3 being 11.3 plus or minus 0.2 centimeters. Now, you may ask the question, well, what if we just measure straight from 1 to 3? Because I'm making less measurements in total, I'm going to have less uncertainty. So if I look at this, I would say, okay, we're starting at 1, or we're starting at 0, and this looks like we go to, it looks kind of in between the lines to my eye. I see 11.35. So I'm getting 11.35 for this. So if I just measure straight like that, I'm going to say D 1 to 3 is equal to 11.35 plus or minus 0.10. You'll notice my uncertainty is 0.10 instead of 0.20. That's because I only made the one measurement. So, using method 1, we got a value of, I believe it was 11.3 plus or minus 0.2 centimeters. Using method 2, we got a value of 11.35 plus or minus 0.10 centimeters. You will notice that I have another digit in method 2. I have to the nearest hundredth of a centimeter because I have less uncertainty. We would say that this value is more precise. The reason is that it goes to the hundredths place instead of the tenths place. That is a more precise value. However, with method 1, we individually measured where it went from 1 to 2 to 3. So we tracked this thing's distance more accurately. So method 1 likely is more accurate. Now, the question is, should you use method 1? Should you use method 2? Well, that is where we leave it to the realm of scientific discretion. In this case, the dots were quite well aligned. There wasn't too much deviation from 1 to 2 to 3. So it's actually a difficult decision in this one. Do we go for the more accurate one or do we go for the more precise one? I will leave that up to you, what you think is the better method. And that's it for the introduction into uncertainty. I hope you found this useful.